Hi everyone. Now we are going to discuss about stability of carbanions. Different factors. Generally, carbanion stability is increased by certain factors. Those factors which increases the stability of carbanion are called stabilizing factors. These are all negative factors like minus I group, minus R group, minus M group. That is negative inductive effect group, negative mesomeric effect group, and negative resonance effect group. Right. And those factors which decreases the stability of carbanion, that are called destabilizing factors. That are all positive factors, that is a plus I group, plus R group, and plus M group, that is positive inductive effect group, positive mesomeric effect group, and positive resonance effect group. Right. Now regarding these concepts, and the stability is also increased by like aromatic character, aromaticity, and also conjugation, that is linear conjugation, cyclic conjugation, and crossed conjugation, and also percentage of s orbital character. So about all these factors with the different examples, now we will discuss. Let's start now. So first one, stabilizing factors. That are all negative factors. Like negative inductive effect group, negative mesomeric effect group, negative resonance effect group, and also aromaticity, and also conjugation, that is linear conjugation, crossed conjugation, and cyclic conjugation. Right. Next one, percentage of s orbital character. Percentage of s character, s orbital character. Right. Okay. Next one, destabilizing factors. That are all positive factors, like plus I group, plus M group, plus R groups. Okay. Yeah. First of all, stabilizing factors. In stabilizing factors, negative factors, that is electron withdrawing group factors. Positive factors are electron releasing group factors. Releasing group, right. First of all, we will discuss about electron withdrawing group factors. For example, a carbon carrying a negative charge. It is carrying a negative charge, right. And here it is R1, and it is R2, and it is R3. So this R3 may be here, it is some is X. What is X? So this X is a some group. It is a group that is electron withdrawing group, which withdraw electrons from the carbanion, right? Because of that, the negative charge is dispersed toward this, it is withdrawing. So that's why by withdrawing electrons, it disperses the charge on the carbanion. If charge dispersal takes place, stability of carbanion increases, because the charge is going on, right? It is dispersed. Okay. So that's why now that means electron withdrawing group. These are groups are some examples will give you, like NO2 group, okay, and cyanide group, and aldehyde group, and keto group, and carboxylic acid group, and ester group. These are all okay examples. If these groups are present, by withdrawing electrons, they disperse the charge on carbanion. Disperse the charge. Disperse the charge on carbanion. If charge is dispersed, then stability of carbanion increases, because it is going on, right, the negative charge. So that's why it increases stability of carbanion. stability of carbanion, right? Is it clear? Okay. That means on the carbanion, if these groups are present, you have to keep in your mind these groups. These groups are present, they increases stability by withdrawing electrons, then the charge is dispersed on the carbanion, because of that it is going to stable, right? Is it clear? Copy it fast. Now we'll discuss different examples. Yeah, next one. For example, CH2, NO2, their carbon carrying negative charge. Next, CH2, cyanide ion, that is carbon carrying negative charge, cyanide group. CH2, chlorine, carbon carrying negative charge, right? Yeah. So, what is the increasing order of stability of these carbanions? Here, this carbon, how many carbons are there? 2 carbons are there. It is NO2 group carrying negative charge, right? You know, generally students are asking, so if the given molecule, which effect is operated? How can we know? There only students are facing problem. Don't worry, the simple thing is, so here inductive effect, resonance or mesomeric, right? Okay. Aromaticity. Now here in this case, when resonance or mesomeric effect is take place, there is conjugation is there. What is conjugation? There is presence of positive double bond, single bond, double bond, single bond character. Alternative double bond, single bond character, right? Or there is double bond, single bond, positive charge, double bond, single bond, negative charge, double bond, single bond, lone pair of electrons, double bond, single bond, and free radicals are there. In these cases, conjugation is take place. The organic molecule, wherever conjugation is there, that molecule undergoes resonance effect or there is mesomeric effect. But here you have to observe it here. So this is what single bond is there. So single bond double bond character is not there. So single bond positive negative charge is there. So what is conjugation here? Single bond double, if double bond is there, then negative charge, then conjugation. But here no conjugation means no resonance effect, no mesomeric effect. Then the thing is inductive effect. That's it, over. Like that you have to check it. Okay, my dear student. Yeah, so now here inductive effect means, you know, NO2 group, according to inductive effect, it is this is minus I group. That is these groups are minus I groups, or according to resonance minus R M groups, minus R groups, right? All these groups are belong to this one, right? So it is a negative inductive effect is operated, okay? And here also can represent for our convenience 2 carbons and cyanide group is there, it is carrying negative charge. So this group is a, okay, this group, this one is a minus I group. And here also carbon, 2 carbons, chlorine. So according to inductive effect, chlorine is also negative inductive effect group, right? Okay. Now, all are negative inductive effect groups. Minus I groups are there. Then which is stable is power of the groups. The power of the groups plays important role. The power of the groups, power of minus I groups. Okay. So that is NO2 group is more power. Next to cyanide group. Next to halogens, that is fluorine, chlorine, bromine, iodine, like that. Okay. So this is chlorine. Okay. So now this I have to keep in our mind, my dear students. Yeah. Then answer is what? If the power of the group is greater, then charge dispersal is more, then stability of carbon is also more. So that's why it is more stable. Next to this one, next to this one. Okay. Is it clear? Right. Next, second example. So this is the way how to study. Clear explanation you will get more. Another example. For example, the compound is like this. So 4 carbons are there. I am taking now. Yeah. So in this case, here it is a negative charge is present here. It is a CH2 minus. Here CHCl. Okay. Here 2 hydrogens. Here 1 hydrogen. Here 2 hydrogens are there. And here 3 hydrogens are there. Right. And here it is negative charge, okay, and here this is chlorine is there here, it is 2 hydrogens, here 2 hydrogens, here 1 hydrogen, here 3 hydrogens, right. So this is a negative charge, here 2 hydrogens, here 2, and here chlorine is there, 2 hydrogens are there. So this is the way, it is very easy to understand the concept, you have to study organic chemistry, Okay. Now in this case, which is stable. So here all are carbanions and the substituent is chlorine is there. All having chlorine is according to here which effect is operated, tell me now. So there is no double bond, okay, there is no double bond, okay, then you have to, there is no conjugation, there is no resonance effect, inductive effect is operated, okay. So here chlorine is minus I group, so minus I chlorine is the only there, right, but the minus I group, there is all are chlorine only, but the deciding one is, distance is different, right. So here it is closer, okay, and it is somewhat distance increases, this again increases. Inductive effect is depends on distance from the source. The distance increases, the effect also decreases. It is negligible after third carbon, right? So that's why here the inductive effect, negative inductive effect or inductive effect is depends on distance. It is depends on distance, okay, depends on distance. Distance from the source, distance from the source, okay. As distance from the source increases, right, so inductive effect, I effect, inductive effect depends on distance. So here distance is less, so that's why it is withdrawing effect is more, it is more withdraw, then charge dispersal is more, it is more stable, right, and here distance increases, stability less, here distance further increases, stability less. So that's why here there is the stability is of carbanion is directly proportional to distance of minus A group, okay. So the conclusion will get what? What is the conclusion will get? The stability of carbanion is directly proportional to distance of minus I group. So the distance of minus I group increases, stability decrease, that is inversely proportional, right, inversely proportional, right, okay. So distance of minus I group is less, stability of carbanion is more, right, yeah, is it clear? Next one, another example. Yeah, CH2 minus, the ring carrying, that is CH2 minus, and here in the para position 1, 2, 3, 4th position. So here maybe NO2 group is present and aldehyde group is present and fluorine is present, right. So which among these are all carbanions, which is more stable, right. Here which effect is operated? So there is double bond, single bond, negative charge. Whenever double bond, single bond, negative charge is there, which effect is operated? Resonance is operated, right. So here what happened? The charge dispersal. So this charge, this negative charge is moving here, then this negative charge move here and it make a bond here, then it is migrated over here, right. You will get, NO2 group means it is like this, right, that is NO2. So then these electrons are split over here like that, okay, got it, yeah. So charge dispersal is take place, okay, the negative charge is dispersed over through the resonance to the NO2 group. It is a withdrawing group, right. So there is according to wherever resonance is take place, which now the NO2 group you have to consider as minus R group or minus I group, right, okay, yeah. So here resonance effect is take place, resonance effect, because here conjugation is present, right. Because of presence of conjugation, okay, what is the conjugation here? There is what is there here? This is a pi bond is there, okay, there is double bond, pi bond is there and sigma bond and negative charge there, right. So because of presence of there is pi bond, sigma bond and there is double bond, single bond and negative charge, double bond, single bond and negative charge, double bond, single bond, negative charge, okay. So that's why conjugation is present. Wherever conjugation is there, then resonance effect is take place, that is NO2 group is a minus I group, okay. So that's why charge dispersal is more, then it is easily stabilized, okay. Then here CHO group, it is also here also what I mean, there is resonance is take place, it is also here also resonance is take place, okay. So that's why it is also minus R or minus M, and here also fluorine is also. So according to inductive effect, halogens are, according to inductive effect, halogens are minus I groups, negative inductive effect, but according to resonance, halogens are plus M group or plus R group, electron releasing groups, right, okay. So that's why here, so this is a fluorine is there, so it is a releasing effect is there, okay. Or for example here, if it is releasing group is there means, so what happens, it is releases electrons, then the charge is not dispersed here. Charge is intensified over the carbanion. Charge increases. Negative charge again increases over the carbanion. Already negative charge is there. It is already carrying. It is unstable. Again it is releasing electron to that. Then the more and more electrons are occupying over the carbanion. So because of that it feels some burden. It is